Practice problem number 2 in chapter 4. The electron configuration for fluorine is going to be represented as F when I'm looking for it on my periodic table, is 1s2, 2s2, 2p5. What is the atomic number of fluorine? How many of its p orbitals are filled? And how many unpaired electrons does the fluorine atom have? So let's find fluorine on our periodic table. Here we see that fluorine is in fact number 9. Okay, we can also see this in the 2p sublevel. And according to the electron configuration, it's got 5 electrons in the 2p sublevel, so we can prove that. 1, 2, 3, 4, 5, and guess what? That's fluorine. So good on us. What is the atomic number of fluorine? Well, it's 9. But what I can do here, like I said, I can add 2 plus 2 plus 5 to equal 9. Okay? Now, where am I getting those from? The superscripts in the electron configuration, right? 2 electrons, 5 electrons. That adds up 9. So you might be wondering, why am I using the same number when I'm being asked for the atomic number, right? Well, this isn't an ion. For however many protons this thing has the same number of electrons. So since we know how many electrons it has, we know how many protons it has. And plus, I said fluorine. I actually say it's fluorine. So fluorine is number 9. Move on. Let's box that out. How many of its p orbitals are filled? Okay. So in order to answer this nicely, we actually need to go and draw an orbital notation. So we are filling the 1s sublevel, we're getting into the 2s sublevel, and then the 2p sublevel. Each of these s sublevels have 1 orbital. The p sublevels have 3 orbitals. Okay? So I have to account for 9 electrons, right? Because there are 9 electrons up here. You can see it. You can read it if you don't believe me. And so according to the off-out principle, I'm going to start at this lower energy level first, and then I'm going to move to the right. According to the pollution principle, I'm never going to have 2 electrons in the same orbital that have the same spin. One's going to be up, one's going to be down. And then according to Hund's rule, when I get to this sublevel that has multiple orbitals, I have to singly fill each orbital before I go back and double them up. Okay? And that's going to be important to answering this second question. Okay? So I have to do with 9 electrons. So 1, 2, 3, 4, 5, 6, 7. Remember, I'm filling each of these with an up spin electron before I go back and double them up with the down spin. All right, so I got to 7, 8, 9. Okay. So the question is, how many of these 3p orbitals have been filled up? Okay. Now, you might be a little bit confused by the wording of the question, and if you are, don't feel bad. Okay, don't worry about it if you are confused, because this wording isn't my favorite, and the reason being, the question is, well, do you mean filled with 1 electron, or do you mean completely filled up with 2 electrons? Well, what I'm really getting at here is how many orbitals are completely filled, meaning doubly filled. As you can see that right here, those 2p orbitals are both doubly filled. So I have 2 filled p orbitals. Last part of the question, how many unpaired electrons does a fluorine atom have? Well, there's only 1 unpaired electron right there. 1 unpaired electron. So again, if you answered for this middle question, right, how many of its p orbitals are filled? If you answered 3, don't feel too bad, because you can make an argument like, oh, that is filled with something. It's not completely filled, and I completely understand. So don't panic if you didn't understand that question. That's the type of situation in which, if you were on a test, you'd simply ask me for clarification. Do I mean filled with anything at all, or do I mean doubly filled or completely filled? And that's something I'll let you know, so you know exactly what I want.